Welcome back, y'all. We're continuing with our topic 16 geometric unit. Okay, we're going to move into another section, 16-2, line segments, rays, and angles. All right, so this builds upon the lines that we worked on 16-1. We're going to build upon it. Okay, so we're going to focus on these things today. So we're going to learn a couple new terms and define them as well, because they're going to start we're going to start applying them to other things. So the first of which is a line segment. Okay, so we know that a line with its two little arrows goes infinitely in both directions. A line segment is just a portion of that infinite line, and it is stopped at 2 points. Okay, remember points from the last one? So if you take 2 points on a line, and you can imagine kind of pulling it out of that infinite line, that's a line segment, all right? A ray is similar to a line segment, except it has a point on one side, and it continues infinitely on from the other side, all right? So typically, line segments and rays, they are identified by variables. So let's call this line segment, here's an A, here's a B. So this is line segment AB. Okay, that's how you would refer to that line segment. Now, with a ray, you can have 2 points on it, and it can still go infinitely. So if I call this point C and that point D, you would refer to this ray as ray CD. Okay? I'm naming the point, and then I'm combining it to tell me what the line segment or the ray is. So again, line segment AB, ray CD, and you would write it like this. Okay, straight up, you would write AB, okay, and that tells me it's line segment AB, and you'd write this one CD. That's how, if you were writing down and referring to this, you would write it, okay? You draw a little picture of the line segment above the name, draw a little picture of the ray above the name, okay? So, using our line segments and using our rays, now we're going to define what an angle is. And an angle is two rays joined at a single point. So, here's a point. We'll call this point Y, okay? And I have two rays that share the same point, and that is an angle. And then, let's see, we'll call that point X. I'm going to add points to it, and Z, because I want to be able to name this. I want to be able to refer it when I talk to it. So, this is called angle X, Y, Z. Right? That makes sense. So you would do it like this. Angle X, Y, Z. Simple. Okay? You write the name of it using your variables, and then you put the symbol above it that refers to what type of geometric thing it is. Whether it's a line segment, a ray, or angle X, Y, Z. Okay? Another important term to know is this point right here where our two rays converge to make that angle, okay? This is called a vertex. That's a cool sounding word that basically just refers to the single point where two angles come together, all right? One is a vertex, multiples are vertices, but either way. So a vertex of angle XYZ is Y, all right? And when you're naming your angle, you put the vertex in the center because it's in the center. That seems to make sense to me, all right? Now, let's take a look at different types of angles, okay, y'all? To begin with, we have a right angle. Now, I think your book does you a disservice. It does not talk about degrees here. I'm going to. So, a right angle, remember, two rays joined at a single point forming a vertex. Okay, at a right angle, it's sometimes called, this marker's dying, it's sometimes called a square angle because it is square. It's also 90 degrees, okay? So if you think of a circle having 360 degrees, okay, or like an Xbox, if you think of a circle having 360 degrees, if an angle is 90 degrees exactly, it is a right angle. If it is not exactly 90 degrees, it is not a right angle, it is a wrong angle. I'm just kidding, that's not a term, but right angle is a term, all right? 90 degrees only. Now, acute angle. Oh, it's so cute. An acute angle, okay, how does that look in comparison to my right angle? Well, it is smaller. So, unless it's a right angle, you use a curved line to denote that angle. And this is less than 90 degrees. Less than 90 degrees. Okay, and I don't mean temperature, I mean angular measurement. So an acute angle is less than 90 degrees. Well, what do you think the obtuse one is? Well, if that one's less than and that one is, an obtuse angle, okay, is going to be greater than 90 degrees. Greater than 90 degrees, okay? It doesn't matter how much greater. This could be 89 degrees, that's still less than 90. This could be 91 degrees, that's still less than 90, which brings me back to that point I made. If it's not exactly 90, it's not a right angle. So you've got your square angle or your right angle, which we're gonna call it right angle. In fact, I don't even wanna have that up there. So we've got our right angle at 90 degrees, our acute angle at less than 90 degrees, and our obtuse angle as greater than 90 degrees. For this section, and a lot of times you won't be given the actual degrees of the angle, you're gonna have to kind of eyeball it and determine which one it is. But that's very obvious that this is smaller than that, and that is larger than that. Okay, so if you can tell just from the eye test, that's what it is. And then lastly, they have what's called a straight angle. And that is exactly what it sounds like. Okay? Remember, in order to be an angle, it must be two rays joined at a single point. This isn't a line. Okay, a line is one that goes on infinitely. This is two separate rays joined at a vertex, and each individual ray goes infinitely. But there is no angle necessarily to it that you could see. So we draw our little circle here. This is 180 degrees. Okay, that's very specific. Is it also obtuse? Yes, because it is greater than 90. But it's 180 degrees. It's a full half circle. Okay? And those are our parts of an angle and our types of angles, okay? And that's 16-2. See ya.